begin with the alkanes. Alkanes. So alkanes are also known as paraffins. Alkanes or paraffins. Do you know the definition of alkanes? What are alkanes? Do you remember the definition of alkanes? Alkanes are, yes, can you say? They are open chain. They are open chain saturated hydrocarbons. Saturated hydrocarbons. Hydrocarbons with a general formula. There is a general formula. General formula. Do you remember it is? What it is? General formula CnH2n plus 2. So alkanes are open chain. That means aliphatic. Open chain saturated. That means carbon-carbon single bonds only. Hydrocarbons composed of hydrogen and carbon only. So, open chain, saturated hydrocarbons with general formula CnH2n plus 2. We know the nomenclature of alkanes. To name the alkanes according to the IUPAC system, the name should end with ANE, ANE. So as in alkane, ANE, ANE is there. So the names end with ANE. So for example, you start from the simplest alkane with a one carbon atom, that is a CH4. We know the name of this alkane, and it is our methane, ANE. See, the name ends with the ANE, methane. The next one, that is a C2H6. C2H6. Two carbon atoms. And the compound is ethane. 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 The next one, C3H8. Three carbon atoms. Propane, propane, ANE again. Then C4H10. That's our butane, butane. Then C5H12. That's our pentane, pentane. So, I have taken some examples for alkanes. All the names end with ANE, ANE. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decaine, etc. These are the names for the alkanes. Now, they are also known as paraffins because they have very little reactivity towards the other reagents. Due to their inert nature, they are inert, somewhat inert. Due to their inert nature, say under normal conditions, alkanes are known as paraffins. They are somewhat inert, inert. So due to inert nature, that means they are not much reactive with other reactants like acids, bases, or whatever it is. The reactivity is less. So they are somewhat inert in nature. So due to the inert nature of alkanes, the alkanes are known as paraffins. Para means little, little, in the sense negative. Affinis, affinis means affinity, affinity. So little affinity. There is no affinity for the other reactants. That means they are inert in nature. And due to the inert nature of alkanes, alkanes are known as paraffins. As we know, the main sources, natural sources of alkanes are petroleum and natural gas. The main sources are petroleum and natural gas. Natural gas. Natural gas. We have seen this. For example, you take the compressed natural gas, CNG. Compressed natural gas, CNG. Or say LNG, liquefied natural gas, LNG. There is a new term now used. That is a PNG, piped natural gas. Piped natural gas. You know, the gas pipeline is going. You have read that in the newspaper. It is under construction. The gas pipeline, as we have seen, the gas pipelines in the metros, say Mumbai, Delhi, etc. Just like a water pipelines, there will be gas pipelines also. And now, here also we are introducing, we have already introduced the, say, the transmission of natural gas through pipelines. And is piped natural gas, that is PNG, piped natural gas. So here there is natural gas. And the main constituent of natural gas is CH for methane. Methane is the main constituent of the natural gas. Whether it is a CNG, compressed natural gas, or a LNG, liquefied natural gas, or a PNG, piped natural gas. The main use of natural gas, that is used as a fuel. That is used as a fuel. The domestic fuel as well as the automobile fuels also. You know, in the metro cities like Mumbai, Delhi, etc., the automobile engines, say for example buses, they make use of natural gas, CNG, compressed natural gas is used instead of petroleum. Say petrol, instead of petrol or diesel, they make use of a natural gas. So natural gas that contains the main constituent as methane, CH4, and it is used as a fuel. Methane, natural gas, is as a fuel. That is the main constituent of, say, the gobar gas, biogas. Say the gobar gas plant, biogas plant, the gas plant that we say build at our home using cow dung. That is the gobar gas plant. They are also the main constituent of the gobar gas or the biogas. It is a methane gas. From the marshy region, the wet marshy region, you can see there is evolution of gas bubbles. And the gas bubbles coming out from the marshy regions, the wet marshy regions, that also contains methane gas. So we can say the main source of alkanes are petroleum and natural gas. That is regarding the natural sources. Now let us see the preparation of alkanes or paraffins. Let us see the methods of preparation of alkanes. Preparation of alkanes. Let us see some important reactions by which we can prepare alkanes. One is the hydrogenation of alkenes and alkynes. Method 1, hydrogenation of alkenes and alkynes. Hydrogenation of alkenes and alkynes. We know in alkenes there are carbon-carbon double bonds. These are compounds with a carbon-carbon double bonds, alkenes. And you know, alkynes contain carbon-carbon triple bond. There will be carbon-carbon triple bond. As you know, in the multiple bond, that is double bond or triple bond, the covalent bonds are not identical. All these are covalent bonds, but the covalent bonds are not identical. You take the case of the double bond. The two bonds between the carbon atoms are not identical. One is a sigma bond and the other is a pi bond. You take the case of alkynes in which there is a carbon-carbon triple bond. Here also the three bonds between the carbon atoms are not identical. Only one is sigma bond. Two are pi bonds. As we know, the pi bonds are more reactive than the sigma bonds. Why? Because the pi bonds are weaker. Pi bonds are weaker than the sigma bonds. So we can easily hydrogenate alkenes and alkynes in presence of a metallic catalyst. The alkenes or alkynes are hydrogenated in presence of a metal catalyst. You can use catalyst as, say, nickel, or you can use platinum, or you can use palladium. All these can be used as the catalysts. These are the catalysts used. Nickel, platinum, or palladium can be used as the catalysts. Say, let us take the reaction of an alkene, say RCH, double bond, CHR, a general case of an alkene, RCH, double bond CHR. And this is made to react with hydrogen in presence of a metal catalyst like nickel. So the mixture of the alkene and hydrogen that is passed over heated nickel. Then the pi bond is broken. There will be formation of a RCH2 single bond CH2 RCH2 single bond CH2R. There is formation of a carbon-carbon single bond or saturated compound. Say, for example, you take CH2 double bond CH2, and that is our ethane or ethylene. And ethane reacts with the hydrogen in presence of a nickel catalyst. Then the pi bond is hydrogenated. What is meant by hydrogenation? Hydrogenation means the reaction with the hydrogen, addition with the hydrogen. That's called hydrogenation. The pi bond is broken. I'll get a CH3, and it is our ethane. Ethane is formed. So in general, alkenes can be hydrogenated. That means alkenes are made to react with the hydrogen. That is called hydrogenation. Reaction with the hydrogen is called hydrogenation. So alkenes can be hydrogenated in presence of nickel catalysts, forming the corresponding alkane. The hydrogenation in presence of nickel, that's called a Sabatier and Sentren's reaction. Sabatier and Sentren's, that is the full name. So Sabatier and Semprens reaction. It's called a Sabatier and the Semprens reaction. So hydrogenation of alkenes, alkynes also, in presence of nickel catalysts. It's called a Sabatier and a Semprens reaction. Sabatier and Semprens reaction. So the reaction takes place, hydrogenation takes place in presence of nickel. Instead of nickel, we can use palladium or platinum also. But in the so-called Sabatier and Semprens reaction, nickel is used as the catalyst. Nickel is used as the catalyst. Similarly, we can take alkynes also, hydrogenation of alkynes. Say, you can write the reaction as R, C triple bond Cr, and this reacts with a hydrogen in presence of nickel. In presence of nickel. Say, both the pi bonds are broken. Both the pi bonds are broken. Then we'll get R, CH2 single bond CH2, R. Let us take an example. CH3, then CH double, no, not a CH, it is a C. We are going to take alkyne. So it is a C triple bond CH. You take an alkyne like this, alkyne. And this alkyne is 1, 2, 3 carbon atoms. 3 carbon atoms. And the compound is propyne. YNE, propyne. Propyne. The ending ANE is replaced by YNE, propyne. And this reacts with hydrogen in presence of nickel, forming, say, CH3, then CH2, single bond CH3, and that's our propane. Propane, the alkane propane is formed. So in general, alkanes can be prepared by the hydrogenation of alkenes, carbon-carbon double bond compounds, alkanes, as well as alkynes, carbon-carbon triple bond compounds. So alkanes and alkynes in presence of nickel, platinum, or palladium as the catalyst. If nickel is used as the catalyst, then the reaction is called Sabatier and Semprens reaction. Sabatier and Semprens reaction. So the hydrogenation of alkenes and alkynes to form alkanes. Okay, let us take the second method. That's called the Wurtz reaction. WURTZ. That is called the Wurtz reaction. So regarding the pronunciation of WURTZ, so you can pronounce it as woods. W-U-U, so woods or words, both are used. So the Wurtz reaction or a Wurtz reaction. And what is it? It is the reaction between alkyl halides. Say alkyl halides. Alkyl halides are made to react with sodium in dry ether. Ether is the solvent. Dry ether. Then the alkyl groups will combine. To form a higher alkane. There is formation of a higher alkane. And the reaction is called the Wurtz reaction or the Wurtz reaction. So let me say something about the word alkyl, alkyl. So word alkyl. Say alkyl is coming from alkane, alkane. You know, say alkanes CH4, that's our methane, methane. And we take the 2, 3 examples. Then C2H6, and that's our ethane, ethane. Take one more, C3H8, and it is propane. All these are alkanes. Now, you remove one hydrogen atom from these alkane molecules. Suppose you remove one hydrogen atom from CH4, CH4, then you'll get a CH3 group. And there is a free valency on the carbon atom. The free valency shown is on the carbon atom. It can be written like that, or say like this also. Both are correct. Free valency. So one hydrogen is removed. And this group is called the methyl group. That is called the methyl, methyl or methyl group. So methyl group, CH3, is formed by the removal of one hydrogen atom from methane. Similarly, from ethane, you remove one hydrogen, then you'll get a C2H5 group, C2H5 group. And this is called the ethyl group, ethyl, ethyl or ethyl group. Similarly, from C3H8, you remove one hydrogen atom, then it will become C3H7, C3H7, and it is called the propyl group or propyl group. And these groups are collectively known as alkyl groups. These are called the alkyl groups. So alkyl groups are the groups, the carbon groups obtained by the removal of one hydrogen atom from the corresponding alkane. So it is called the alkyl group. Methyl group, ethyl group, say propyl group, butyl group, pentyl group, hexyl group, etc. One carbon atom less than the corresponding alkane. And that group is called the alkyl group. The alkyl groups are generally represented by capital R, capital R. So R stands for the alkyl group. And what is the formula of R group? R group. The formula of R group is CnH2n plus 1. 2n plus 1. Because CnH2n plus 2, that is alkane. CnH2n plus 2, that is alkane. From that, one hydrogen is removed. So the remaining part will be CnH2n plus 1. And that group, CnH2n plus 1 group, or the capital R group, that is called the alkyl group. Okay. Now you come to the alkyl halides. Alkyl halides. What are halides? Say chlorides, bromides, iodides, etc. So these are the halides. You come to alkyl halides. So alkyl halide may be generally written as RX. RX. Where R is the alkyl group. Say like methyl group CH3 or ethyl group C2H5 or a propyl group C3H7, etc. So the alkyl halide, that is RX. Alkyl halide RX. And this is made to react with the sodium in dry ether. Then two molecules of alkyl group will react. So plus 2 sodium plus one more alkyl halide. Say XR. The medium, the solvent is dry ether. Dry ether. Dry ether is the solvent or the medium. Then there is removal of NaX, NaCl, NaBr, NaI, etc. NaCl, NaBr, NaI. And the products, the organic products obtained is R. That means there is coupling of two alkyl groups. There is a coupling of two alkyl groups. Coupling of two alkyl groups. When alkyl halides are made to react with sodium in dry ether. So wherever you see sodium and dry ether, immediately you think of the Wurtz reaction. The Wurtz reaction. That is the coupling of the two alkyl groups, giving a higher hydrocarbon. Say in the hydrocarbon, there will be double the number of there will be double the number of carbon atoms. Double the number of carbon atoms compared to the alkyl group. Because two alkyl groups are coupled. Two alkyl groups are combined to form a hydrocarbon, an alkane, containing double the number of the alkyl group. And the reaction is called the Wurtz reaction or Wurtz reaction. RX is an alkyl halide. And this reaction can be written in another way also. Say it's RX, and this reacts with the sodium in dry ether. Immediately you think of the Wurtz reaction. Then there is removal of NaX, and two alkyl groups will couple together, giving an alkane containing double the number of the carbon atoms as in the alkyl group. And such a reaction is called the Wurtz reaction. So, alkyl halide RX plus sodium and dry ether. Alkyl halide RX, for example, CH3Cl, CH3Br, CH3I, etc. plus sodium and ether. Immediately, the two CH3 groups combine together. Let us take a typical example. Say CH3Br. That is methyl bromide or bromomethane. It is a bromomethane or methyl bromide. It is also known as methyl bromide. And this reacts with the sodium in dry ether. Ether is the solvent. Alcohol, water, like that, ether is also a solvent. Dry ether. Then what will be the product obtained? There will be NaBr, that I agree, minus NaBr. It is there. But what will be the organic product obtained? There will be coupling of two methyl groups. So you'll get CH3. That is ethane. Ethane is formed. See, there is coupling of two methyl groups. Coupling of two alkyl groups. And such a reaction is called the Wurtz reaction. So, alkyl halide or haloalkane. Alkyl halide is also known as haloalkane. We will study that in detail in second year, alkyl halide. So, alkyl halide plus sodium and a dry ether. Then the two alkyl groups coupled with the formation of an alkane containing double the number of carbon atoms. That is because two alkyl groups are coupled together. And such a reaction is called a Wurtz reaction or a Wurtz reaction. Okay, so that is the second method for the preparation of alkanes. Now you come to the third method, and it is called the decarboxylation. Decarboxylation. Decarboxylation reaction. Decarboxylation reaction. What is meant by decarboxylation? That is the removal of the carboxyl group as carbon dioxide. From the carboxyl group, carbon dioxide is removed. The carboxyl group is removed. You know, carboxyl group is present in the carboxylic acids. Carboxylic acids. You take sodium salt of carboxylic acids. Sodium salt of carboxylic acids. It is called the sodium carboxylate. Sodium carboxylate. Sodium salt of carboxylic acid. It's called a sodium carboxylate. And this is heated with soda lime. That is heated with soda lime. Soda lime. Soda lime is a mixture of soda and lime. Soda is caustic soda, and lime is quicklime calcium oxide. And this mixture is called soda lime. So sodium carboxylate, sodium salt of carboxylic acid is heated with a soda lime. Then the carboxyl group is removed. The carboxyl group is removed. There is a decarboxylation with the formation of alkane. There is formation of alkane. And the reaction is called decarboxylation because there is a removal of the carboxyl group. There is a removal of the carboxyl group. The carboxyl group is removed as carbon dioxide. There is a liberation of carbon dioxide minus CO2. Minus CO2. CO2 is removed from the carboxyl group. And the reaction is called decarboxylation. Okay. Since sodium carboxylate, sodium salt of carboxylic acid, is heated with soda lime, the reaction is called soda lime distillation. This is also known as soda lime distillation. It is also known as soda lime distillation of sodium carboxylate. Because sodium carboxylate, sodium salt of carboxylic acid, is heated with soda lime. And so the reaction is called soda lime distillation. During soda lime distillation, a carboxyl group is removed. And so it's called decarboxylation, removal of the carboxyl group. Let us take a general reaction. R C double bond O Na. That is a sodium salt of a carboxylic acid. You know, carboxylic acid is RCOOH. RCOOH. That is carboxylic acid. You have seen the functional group, carboxyl group, COOH group, the carboxyl group. Now, the sodium salt, RCOONA, that is sodium carboxylate or sodium salt of carboxylic acid. And this is heated with the soda lime. Then, say the reaction will be like this. NaOH, and there is a CaO that is heated. Then what will happen here? There is a removal of the carboxyl group. The carboxyl group is removed. So you combine all this. What is in the box? You combine what is in the box. Combine together. What you get? The molecular formula of the atoms within the box. Na2CO3 minus Na2CO3. That's the product. Now you come to main organic product. It is RH, where R is the alkyl group. You have seen on the alkyl group. So to the alkyl group, hydrogen is added. Hydrogen is added. Then we get the corresponding alkane. Okay. Let us take one example. CH3, C double bond O, O, N, A. That is the sodium salt of acetic acid. Sodium salt of acetic acid. It is called sodium acetate. Sodium acetate. Salt of acetic acid. Acetate. Salt of acetic acid. Acetate. Sodium acetate. And this reacts with the sodium carbonate. Soda lime. This is heated with the soda lime, NaOH, in presence of CaO. What is the product obtained? There is a removal of the carboxyl group, and hydrogen is added to the alkyl group CH3, so that it becomes a CH3H or CH4. That's our methane. CH4 methane is formed. CH3H or CH4 methane, and the other product will be Na2CO3 minus Na2CO3. So during this reaction, there is a removal of the carboxyl group. The carboxyl group is removed. COO, that group is removed. And so the reaction is called decarboxylation. Removal of the carboxyl group is called decarboxylation reaction. There is formation of the alkane. So that is the third method for the preparation of the alkanes. Now you come to one more important method for the preparation of say alkanes. It is called a Kolbe-based electrolytic method. Electrolytic method. Kolbe-based electrolytic method. Kolbe-based electrolytic method. Here, sodium or potassium salt solution of carboxylic acid is taken. Sodium or potassium salt of carboxylic acid is taken. So sodium or potassium salt of carboxylate. Sodium or potassium salt of carboxylic acid. Salt of carboxylic acid. Solution. You take the solution. Take the solution of sodium or potassium salt of carboxylic acid, and this is electrolyzed. There is a electrolysis. So electrolysis of an aqueous solution of sodium or potassium salt of carboxylic acid. Then we'll get alkane at the anode. At the anode, alkane is formed. Let us write a general reaction. Sodium or potassium salt of carboxylic acid. That is R, C double bond O, Na. One more. R, C double bond O, Na. And this is electrolyzed. Aqueous solution is electrolysis. The solution is electrolyzed. During electrolysis, say the breakage is like this. The sodium salt or potassium salt, it breaks like this. Sorry. This not here. Okay. Now the breakage is like this. So the products obtained will be R. The two alkyl groups are coupled. The two alkyl groups are coupled. Plus, then CO2, CO2, to CO2. And these two compounds are formed at the anode. These are formed at the anode. Plus, at the cathode, what happens? There is sodium. Sodium reacts with the water with the formation of a sodium hydroxide and hydrogen gas. So, NaOH. Sodium hydroxide plus hydrogen. And these are obtained at the cathode. So, by the electrolysis of an aqueous solution, water solution of sodium or potassium salt of carboxylic acid will give us an alkane in which the two alkyl groups are coupled together with the formation of an alkane, and that is formed at the anode. There is carbon dioxide also at the anode. Say, for example, you take acetate, sodium acetate, CH3, COO, sodium acetate. One more, CH3, COO, sodium acetate plus 2H2O. Electrolysis will get CH3 plus 2CO2 plus 2NaOH plus hydrogen. These are formed at the anode. So at the anode there is ethane, CH3, ethane, and at the cathode there will be the formation of hydrogen gas. So the electrolysis of an aqueous solution of sodium or potassium salt of a carboxylic acid to form an alkane, and that's called one thing is mixing spelling. See, KOL, Kolbe, KOLBE, Kolbe is electrolytic method. Then the two alkyl groups coupled with the formation of a hydrocarbon containing R2. To the two alkyl groups are coupled, and that's formed at the anode. And the reaction is called a Kolbe, Kolbe, KOLBE. Kolbe is a electrolytic method. So these are the four methods for the preparation of alkanes in the lab. Let me stop now.